ever pondered where the heat beneath the Earth's surface goes? It's an intriguing question, isn't it? This heat, known as geothermal energy, is a hidden powerhouse, a vast renewable energy source that our planet continuously generates. How does this happen, you ask? Well, the Earth's internal heat is produced in two main ways. First, it originates from the radioactive decay of minerals deep within the Earth's mantle. Second, it comes from the residual thermal energy from when our planet was formed billions of years ago. This heat doesn't just vanish, it remains trapped beneath the Earth's surface, biding its time. It's like a kettle on a slow boil, with the Earth's crust acting as the lid, keeping all that heat contained. So that's the secret of the Earth's hidden heat. But how do we tap into it? Let's uncover that next. The Earth's internal heat isn't just sitting idle, it's a powerhouse waiting to be harnessed. So how do we turn this heat into usable energy? Welcome to the world of geothermal power plants. First off, let's talk about dry steam plants. Imagine a kettle whistling away on a stove. Now imagine that kettle is the Earth, and the steam it releases is a direct result of the heat from deep within. Dry steam plants tap into this steam, funneling it from the ground to drive a turbine that spins a generator. Simple, efficient, and incredibly powerful. Next, we have flash steam plants. These plants are a bit like pressure cookers. They take high-pressure hot water from deep within the Earth, reduce its pressure, and voila! The sudden drop in pressure causes the water to flash into steam. This steam is then used to drive a turbine, spinning a generator to produce electricity. Lastly, we have binary cycle power plants. These plants are a bit like a relay race. The heat from geothermal hot water is passed on to another liquid that boils at a lower temperature than water. This heat transfer causes the secondary liquid to vaporize, turning a turbine in the process. It's an ingenious system that ensures not a single degree of Earth's heat is wasted. Each of these plants works in its own unique way, but they all share a common goal: to harness the Earth's geothermal energy and convert it into usable power. They do this by tapping into hot water reservoirs, steam, or the Earth's internal heat, and the result is a sustainable and environmentally friendly power source that produces significantly less greenhouse gases compared to fossil fuels. Geothermal power plants are commonly found in areas with high geothermal activity, such as geysers, hot springs, and regions near tectonic plate boundaries. These are the hotspots where the Earth's heat is most accessible, providing an abundant source of energy that is just waiting to be harnessed. So, we've tapped into the Earth's hidden heat, but how does it stack up against other forms of energy? Geothermal energy is just one player in the energy game. How well does it perform when compared to others? When we talk about energy, we're often dealing with a diverse spectrum of sources, each with its own merits and drawbacks. Let's see how geothermal energy stacks up against some of the other heavy hitters in the energy sector. First, let's consider efficiency. In energy terms, efficiency is a measure of how much input energy gets converted into useful output. Here, geothermal energy shines brightly. Unlike solar and wind power, which are dependent on weather conditions, geothermal energy is available 24 hours a day, 7 days a week. This constant availability gives geothermal power plants a high capacity factor, meaning they can often operate at close to their maximum output. Now let's turn our attention to sustainability. Sustainability refers to the ability of an energy source to provide power over the long term without depleting the Earth's resources. Geothermal energy is considered a renewable resource because it's powered by the Earth's internal heat, which is continuously replenished by radioactive decay. This makes it a more sustainable choice than fossil fuels like coal and natural gas, which are finite resources. Finally, let's discuss environmental impact. Here again, geothermal energy outperforms many other energy sources. While all energy production has some environmental impact, geothermal energy produces significantly fewer greenhouse gases than fossil fuels. Plus, geothermal power plants have a smaller physical footprint than many other types of power plants, reducing their impact on local ecosystems. However, it's important to note that geothermal energy isn't without its challenges. These include high upfront costs, location dependence, and potential for local environmental impacts. But with continuous advancements in technology, these challenges are being addressed. Geothermal energy certainly holds its own against other forms of energy, but where do we use it? So, we've harnessed the Earth's hidden heat. Where can we put this energy to work? Let's dive into that, shall we? One of the most prevalent uses of geothermal energy is for generating electricity. By tapping into the Earth's internal heat, we can spin turbines and power generators. Dry steam, flash steam, and binary cycle power plants all provide unique ways of achieving this. Whether it's through using steam straight from the ground, reducing the pressure of high-temperature water, or transferring the heat to another liquid, we can convert the Earth's thermal energy into usable green power. But that's not all. Geothermal energy is also a champion in the realm of heating and cooling buildings. By utilizing the stable temperatures underneath the Earth's surface, we can create geothermal heat pumps. These ingenious devices can heat buildings in the winter by extracting the Earth's natural warmth and cool them in the summer by transferring excess heat back into the ground. It's a beautiful cycle that uses the Earth's natural temperature stability to our advantage. But the applications don't stop there. Geothermal energy can be used in agriculture for warming greenhouses and soil, helping to promote plant growth even in colder climates. It can also be utilized in industrial processes that require heat, such as pasteurization and drying. Oh, and let's not forget about the natural beauty of geothermal hot springs. Not only are they a stunning spectacle, but they can also be used for therapeutic bathing and wellness retreats. And the best part, all these applications of geothermal energy are sustainable and environmentally friendly. They produce far fewer greenhouse gases compared to their fossil fuel counterparts. So whether it's lighting up homes, warming our buildings, supporting our agriculture, or powering industrial processes, geothermal energy is there, working tirelessly beneath the surface. It's a testament to the incredible power and versatility of our planet. As you can see, geothermal energy is incredibly versatile. But where in the world can we find it? Let's explore that in our next scene. Geothermal energy isn't everywhere, so where are the hot spots? Let's dive into that. First, let's talk about geysers. These are nature's hot water fountains, shooting up a column of steam and hot water into the air. They occur in regions of active volcanic activity, where magma is relatively close to the surface. The most famous geyser, Old Faithful in Yellowstone National Park, United States, is a prime example of a geothermal hotspot. Next, we have hot springs, which are pools of water naturally heated by the Earth's internal heat. They are found all over the world, from the Blue Lagoon in Iceland to the onsen in Japan. But it's not just about relaxation and rejuvenation. These hot springs are potential sites for harnessing geothermal energy. Now let's get a bit technical. Areas near tectonic plate boundaries are also known to be geothermal hotspots. The Earth's crust is divided into several large plates that float on the semi-fluid layer beneath. At the boundaries where these plates meet, magma from the Earth's mantle can reach close to the surface, heating the rocks and the water they contain. This creates an easily accessible source of geothermal energy. Places like the Pacific Ring of Fire, a major area in the basin of the Pacific Ocean, are brimming with such geothermal activity. Lastly, there are areas known as geothermal reservoirs. These are underground pockets of hot water and steam, trapped in porous rock or fissures. They can be found in various parts of the world, often several kilometers beneath the Earth's surface. Drilling into these reservoirs can provide a substantial source of geothermal energy. In a nutshell, geothermal hotspots are often associated with regions of volcanic activity, tectonic plate boundaries, and certain underground formations. But it's important to remember that while these places are prime for geothermal energy extraction, technology also allows us to harness this energy in areas where geothermal activity is less obvious. From beneath our feet to powering our lives, geothermal energy is indeed a hidden wonder. We've journeyed from the Earth's core to its surface, uncovering the power of geothermal energy. We've seen how this renewable energy source, born from the heat beneath our feet, is harnessed through dry steam, flash steam, and binary cycle power plants. Each of these plants plays a significant role in transforming the Earth's natural heat into electricity and direct heat applications, providing a sustainable and versatile energy source. This journey has also led us to understand the environmental benefits of geothermal energy. With its low greenhouse gas emissions compared to fossil fuels, geothermal energy stands as a powerful ally in our fight against climate change. We've explored geothermal hotspots around the globe, highlighting the vast potential of this energy source. Geothermal energy is not just a scientific curiosity, it's a practical solution for a sustainable future. Next time you feel the warmth of the Earth, remember the hidden powerhouse beneath your feet.